Okay, so our lesson for today is how to factor a difference of squares. And in this lesson, we're going to learn how to recognize a difference of squares expression. And then once we know what a difference of squares expression is, we're going to learn how to factor a binomial that is a difference of squares using that method. Okay, so let's have a look. So first of all, just to review what a square and a square root number is. So the square of a number is always a number multiplied by itself. Okay, so the square of a number is a number multiplied by itself. So for example, if you have 4 squared, that means 4 times 4. A number 4 multiplied by itself. The square root of a number is some value that when multiplied by itself produces that number. Okay, so for example, if we had something like 16, the square root of 16 would be what number can we take that when we multiply it by itself, we end up getting 16. And so that's 4 and 4. Okay, the square root symbol, which is this thing, represents always a positive square root. And then what's important to remember here are what perfect square numbers are. And these are numbers whose square root is a whole number. So for example, I have just a bunch of squares written here. You know, this squared here, let's say it's 1 by 1. Every side is 1 unit. Right? This area, length times width, would be 1 times 1, which is 1 squared, which is 1. So the area here is 1. And maybe this one here is, say, 2 by 2. This area would be 2 squared, which would be 4. This one here, 3 by 3, this area would be 9. So 3 squared is equal to 9. Now let's get a little bit bigger. So suppose this area was equal to, say, 25. If the area was 25, what do the side lengths have to be? Right, well, think about it. What two numbers, when you multiply them together, exactly the same numbers will give you 25? Well, that's 5, right? So this is 5 by 5. So we say the square root of 25 is 5. We could keep going. Let's say this area is 36. Let's figure out the two numbers, length and width, multiplied together, that give you 36. You would take the square root of 36, right? So this is 6 by 6. And now just if we were to extend it to variables, suppose this is x, and this is x as well, then the area, length times width, x, multiplied by x, is x squared. So our perfect square values then, just so we know what a perfect square is, 1 is a perfect square because the square root of 1 is 1. 4 is a perfect square because the square root of 4 is 2. 9 is a perfect square because the square root of 9 is 3. 25 is a perfect square because the square root of 25 is 5. 36 is a perfect square because the square root of 36 is 6. Okay, and x squared is a perfect square because the square root of x squared is x. Okay, so these numbers are perfect square. A number that isn't a perfect square would be something like, you know, let's say a number like 32. So 32 is not a perfect square. And the reason for that is because there are no two whole numbers that are the same that multiply to give you 32. Right? Like 32 could be 1 times 32, right? 2 times 16. 4 times 8. I think that's it. Those are all the factors of 32, right? But none of these numbers are identical. So if you were to take the square root of 32, you'd have to get into a decimal number. So the square root of 32 is, approximately, if you use your calculator, 5.65684, etc., etc., etc. Right? Because this isn't a whole number, 32 is not a perfect square. Okay, as opposed to, say, 49, which is a perfect square. Okay, and the reason for that is because the square root of 49 is 7. Okay, it's a whole number, not a decimal. Okay, so this is what perfect squares are, square numbers and square roots. This is very important when we're learning about difference of squares. Okay, so in the next little part here, what I want to show you is how do we recognize a difference of squares expression. In order to do that, I kind of want to show you just an expansion of two binomials. So x plus a multiplied by x minus a. If we expand this using FOIL, all right, so if we use FOIL here, first, outside, inside, last, x times x is going to give us x squared. X times negative a, so first we did x times x, then we're going to do x multiplied by negative a, that's going to be negative ax. Then a multiplied by x is positive ax. And then a multiplied by negative a positive multiplied by a negative gives us negative. And then a times a is a squared. Now you should notice that these middle terms here, negative ax and positive ax, cancel out. That's like negative 1 plus 1. That gives us 0. So these things cancel out. And so we're just left with x squared minus a squared. Okay? And so this expression is what a difference of squares is. It is the difference, the subtraction symbol, of two terms that are squares, or perfect squares. All right, x squared is a perfect square, and so is a squared, also a perfect square. Okay, so just to recap that, an expression can be considered a difference of squares if, number one, the expression is a binomial. So if you have a binomial, only two terms, if the two terms are being subtracted, and if the two terms are perfect square terms. If all three of these things are true, then what you have is a difference of squares. Okay. Okay, let's look at how to factor a difference of squares then. It's very, very simple. All you have to do, take the square root of the first term and the square root of the second term. Okay, set up two brackets, one expressing the sum of the square roots and one expressing the difference of the square roots. Okay, so let's take a look at this. So this one here, example 1a, we have 4x squared minus 25. All right, to factor this, so first of all, let's check to see if it's a difference of squares. First of all, it's two terms, check. The first criteria is met. The two terms are being subtracted, that's true. And the two terms are both perfect square terms. So to factor this, here's what we're going to do. We set up two brackets. We take the square root of the first term, the square root of the second term. And so the square root of 4x squared is 2x. And we put 2x at the beginning of both binomial terms. And then we take the square root of 25, which is 5. We write that in the second spot of both binomial terms. One we write minus, one we write plus. And that's it. We could have made this one plus and this one minus. It doesn't matter. Okay, so B, the same sort of thing. binomial, two terms, both perfect squares being subtracted. So this is a difference of squares. So we set up two brackets. We take the square root of the first term, which is 6x, square root of the second term, which is 1. We write minus, we write plus. So not much more there. There are some little twists though. So for example, taking a look at this one here, C, checking to see if this is a difference of squares. Well, it is a binomial, and 25y squared is a perfect square, and so is positive 1, if we ignore that negative for just a second. But these two terms are not being subtracted, they are being added. So it's not a difference of squares, but we could rearrange this to write it this way. 25y squared first, right? So the 25y squared is positive. So it's still positive here. We don't have to write that plus. But if we write the negative 1 as the second term, we write it this way. And now you can see that, we're able to factor this with a difference of squares. Whenever you're writing polynomials, they should always be written in descending power of the variable, right? So because we have a squared term here and then we have a constant term, the squared term should come first before the constant term. Okay, so now we'll factor this. So we take the square root of 25y squared, that's 5y. And then the square root of 1 is 1. 1 we write plus, 1 we write minus. All right. Now this one here, same sort of thing. All right. We want to write this as the subtraction of two terms, not the addition of two terms. So I can rewrite this as 18x squared minus 8. Okay. So now we have two terms. We have a binomial, and we are subtracting the two terms. But the problem here is that 8 is not a perfect square, and 18 is not a perfect square. Now, what you should always do before you factor any polynomial is look for a common factor. All right, so can we think of a number that we can divide 18 and 8 by? And that number would be 2, right? We can divide 18 by 2, and we can divide 8 by 2. So we'll common factor out the 2. So we write the number 2, and then we open up a set of brackets. So right now I'm common factoring, not using difference of squares, but common factoring. 18x squared divided by 2 is 9x squared. And negative 8 divided by 2 is negative 4. And now you'll see that this expression here is a difference of squares. And so this can be factored. So we rewrite the 2. The 9x squared minus 4 gets rewritten as 2 brackets. Square root of 9x squared is 3x. Right, 3x in the front of both brackets. Square root of 4 is 2. 1 we write minus, 1 we write plus. And so now this original binomial can be rewritten as the product of three terms. 2 multiplied by 3x minus 2 multiplied by 3x plus 2. Okay, 2 more examples. This example here I just wanted to show you because it has a fraction. So fractions can also be considered perfect squares. So this factors 2. The square root of 25x squared is 5x. Now the square root of 1/4 is 1/2. So if you're thinking about the square root of a quarter, that's the same thing as saying the square root of 1 over the square root of 4, which is 1/2. So minus 1/2 and plus 1/2. And now this last one looks complicated, but it's not all that bad. The only difference here is that there are some variables whose power is larger than 2. all right, or whose exponent, I should say, is larger than 2. So all even exponents represent perfect squares, right? So this one here would look like this. The square root of 49 is 7. The square root of x to the exponent of 4 is x squared. And the square root of y to the exponent 6 is y cubed. So 7x squared, y cubed. Okay, and that's because 7 times 7 gives us 49. X squared times x squared gives us x to the 4. And y cubed times y cubed gives us y to the 6. If either of these exponents were odd numbers, like say 5 and 7, then we wouldn't be able, those would represent terms that are not perfect squares. All right, now the square root of 100z squared is just 10z. 10z here, 1 minus, 1 plus. Okay, and that's the technique of difference of squares. So it involves just square roots and negative signs and positive signs.